So this will be the second time I've tried recording. My kids have been too loud for me. This was supposed to be the actual last in-person lesson I taught you. But life doesn't work out the way we want it to work. Now, a student's first step in solving the equation 3 to the 4x plus 1 equals 27 was to rewrite 27 as 3 cubed. If you're not writing that line down, you're not trying. Now, somewhere along the line, somebody showed you this property. It said if b to the x equals b to the y, then x is y. When Daddy's done with the board, you can, okay? I promise. So since that's true, since these bases are both 3's, I can say 4x plus 1 is 3. So this makes perfect sense. Now is it to select all? There's more than one answer to this. There is. Mason, please don't touch my board. I don't have the patience right now. This is a technique I never taught. I never saw the point in teaching, although looking at it, it's pretty elegant. It's pretty high level too.
There's nobody here.
They're going to watch a video tomorrow night, Emmett. They're not going to want to do it, but they're going to watch it. Okay? Let's see what happens if we throw this at this thing. We take the log base 3 of 3 to the 4x plus 1 equals log base 3 of a 3 cubed. Now, you are supposed to memorize this property. Maybe you didn't memorize this property. Maybe you're familiar with what you're allowed to do. If you have a log of something to the r, then r log a. Exponents can be moved out front. So I can take this thing right here and put it there. Same thing with this.
Why do you do that?
4x plus 1 times log base 3 of 3 is equal to 3 log base 3 of 3. So the kid who did this has got a pretty good concept, understands logarithms for sure. They do. And heck, it might be worth teaching next year to maybe get some of those ideas in kids' heads. Now, some of you know what log base 3 of 3 is worth. Some of you don't. Log base 3 of 3, it is 1. Now, if you don't see that, if you don't know that, this says what power of 3 creates a 3. But if you don't know that, maybe you remember this rule, that log base b of a is the natural log of a over the natural log of b. So if I apply that to log base 3 of 3, I would have natural log of 3 over natural log of 3, which, by gosh, is 1. Something divided by itself is always 1. Yes, you drew, didn't you? Now, because these are 1's, they're gone. And we end up with 4x plus 1. Mason, you're messing me up, buddy. Equals 3. The exact same thing we had there. Buddy, don't. There you go. Good job. That's enough. That's enough. I got to work. I know. Why does it make sense to solve the equation? What's wrong? Okay. Hold on. I got to pause this video. Mason, please stop. Please stop. Man, I just lost my cool with y'all. Please stop. And I'm back, hopefully. Let's see here. Why does it make sense to solve the equation 2x squared minus 128 equals 0 using the square root method rather than the quadratic formula? So you may not remember what the square root method is. The square root method is done by literally taking square roots. Now, let's think about this. If we did the quadratic formula, we would have 2x squared plus no x minus 128 is 0. And there's things we would do. We would pull a 2 out. We'd have x squared minus 128 is 0. Sorry, minus 64. That's kind of the kicker right there. Now also, if you did the quadratic formula, if you do it, you'd have this b value of 0. It just seems silly. It doesn't make sense to the quadratic formula because factoring is plain and simple and the square roots are simple. But if you do this thing by hand using what they call the square root method, it's a pretty quick problem. You would move this over. 2x squared is 128. You would divide by 2, and then you'd have x squared is 64. Now, it says 2 is a factor of 128. Yeah, that's true, but it's not the real reason. This is what I was alluding to. There is no x term. It's really silly to use a quadratic formula, which is going to be longer, when there is no x term. It's silly. That's definitely false. That is a quadratic equation. 128 is not a perfect square. I don't know its square root. Please don't, Mason. Please don't. Okay, when Daddy's done, you can draw. But right now, Daddy needs to get done so we can get home and take care of Mommy, okay? Buddy, I have to get done and take care of your mother. Solve the equation. Root 3x minus 1 equals 3x minus 1. Now, here's where extraneous stuff comes into play. It's kind of likely that the state might say, what is the extraneous solution if it has one? Now, this one's pretty straightforward. The opposite of square rooting is squaring, so we square both sides. Now, if you think this is 9x squared plus 1, you're wrong. Please don't write on my floor, Emmett. You square something by writing it twice. When you square a square root, you get the contents inside. Here, Jesus would FOIL. 3x times 3x is 9x squared, minus a 3x, minus another 3x, plus a 1. We still have the 3x minus 1 on the left. We're going to use the zero product property. We're going to set it equal to 0. Oh, no, sorry. I don't need to jump ahead. Sooner or later, I'm going to use it after I clean this up by combining like terms. And now I'm going to shift everything right so I can have a 0 on the left. Mason, please don't draw on Daddy's laptop. What is wrong with you two? Not my board either. If I do negative 6x minus 3x, I get negative 9x. If I do 1 minus the negative 1 plus 2. Really? Huh. That stinks. I was pretty sure this one had a nice answer. Maybe it does. Please back away, son. Let's try to factor it. If it doesn't factor, I'll turn around and do the quadratic formula. It ain't going to take 9. 3 and a 3 ain't going to work. So what we have here is we have a problem when I did the problem, because this won't work either.
It's on paper, not on the desk.
Oh, it does work. I'm sorry. There's something wrong with me. It's probably these annoying kids of mine. It does factor. Negative 1 times negative 2 is positive 2. This creates a negative 6x. That creates a negative 3x. And this will tell me that x is a third if I use the zero product property, or x is 2/3. Now, are either one of those extraneous? No, they both work. If you take the third and plug it in right here, 3/3 is 1, 1 minus 1 is 0. Here, 3/3 is 1, 1 minus 1 is 0. The root of 0 is 0. And the 2/3 works as well. Yes, Emmett.
Remember swiping on your...
Okay, please let me record. I'll wash that up later. Don't be a tattletale.
It's not one of the kids' desks.
It's okay, Emmett. Please let me record so we can get home. Okay?
Don't show on my desk.
Now, let's check this one. This one, by the way, works, and I guess I didn't show that. 3 times a third minus a 1 is going to be the root of 1 minus 1, which is 0. That's fine. The right-hand side, 3 times a third minus 1 is 0. That's good. They check out. We've got the same thing on the left we see on the right. If I use the 2/3, 3 times 2/3 minus 1 is going to give me the root of 2 minus 1, the root of 1, which is 1. Now on the right-hand side, 3 times 2/3 minus 1 is again 1. So these are both real. Neither one of them is extraneous. Extraneous is something you got to be on the lookout for. If we don't find one of the notes, I'll make one up. Solve this radical equation. This is a tough one. It really is a tough one. What you need to do is you need to isolate a square root and then fix it. So this one's already by itself, and I'm going to square it. If I square one side, I got to square both sides. And if you square something, that means you write it twice, kids. It doesn't mean you just square what's inside. It means you write it twice. If you still think to square something means to square what's inside, you haven't learned to think. Squaring does counteract radicals, so it frees that up. Now you're going to have to do the good old FOIL method here. Root x times root x is x, plus another root of x, plus another root of x, plus a 1. The left-hand side is still x plus 1. Now what I have on the right, when I clean up and do like terms, is x plus 2 roots of x plus 1. And the left is x plus 1. Oh, this is kind of interesting. There's a whole lot of stuff in balance. What I want to do is I want to isolate this guy right here. I like how this worked out. So that's the wrong way. If I take this x and move it over, and I take that one and move it over, I get 0 equals 2 root x. You ought to know what x is now, but if you don't, you're going to divide by 2. You're still going to have 0 equals root x. To counteract the radical, you're going to square both sides. A 0 squared is still 0, and ta-da, 0 is x. Does it make sense? It does make sense, because if you put a 0 here, you're taking the square root of 1, which is 1. If you put a 0 there, you'll have root of 0, which is 0, plus 1, which is 1. So it makes sense. And none of these talked about the extraneous solution. So I need to do another example, and I'll try and get it in your notes. That needed to be talked about. I thought I picked ones that had an extraneous. So let's look at that 14. Let me snipe that real quick. Sinks has already made copies of these notes, so now I get to make new copies, and I get to be up here even longer. If you learn one thing from me, please learn dedication. As stressful it is. I'd love for you to learn some math. Which equation has an extraneous solution at x equals -3? Now the deal is, the root of x can only return answers greater than or equal to 0. That's it. I can only return things that are greater than or equal to 0. So if you take this -3 and put it right there, this would say equals 1 minus the -3, which is 4, which is positive. That passes the test. You take a -3 and put it right there, that would be a -3, which is 3, which is positive, passes the test. You put it right here, you get 2, which is positive, passes the test. You put it right here, you get a -2. Square roots, at least the square root function, only returns positive answers.
Daddy, I want my shoes on.
I don't have your shoes, they're in a truck. And you don't need your shoes. You don't need your shoes because your feet are all messed up, okay? Your skin is broken. You need to let it heal.
I want shoes. I'm going sorry.
Where was I? What you see us introduce a lot of the time is the plus or minus. That's where we get these negative answers from. But by default, it's always supposed to be positive. Let me pause the video for this 5-year-old so that you don't have to hear it. I'm working on you, son. And I'm back for like the third pause here. This is old. They do like to put these on the non-calculator part of your test. Now I'll show you how to do it in a calculator, obviously, too. At a baseball game, 2 pretzels and 5 hot dogs cost 30. Please be quiet. Stop. Just be quiet, please. Damn it! Drop it. At a baseball game, 2 pretzels and 5 hot dogs cost $31.25. So I'm just going to kind of stick with P and H. 2P plus 5H is $31.25. 4 hot dogs and 4 pretzels. There's 4 pretzels plus 4 hot dogs is $32.25. How much does each hot dog cost? How much does each pretzel cost? Write your answers in dollars. Noise, kids. Noise. You do need to know how to solve these by hand. You do. Plain and simple, you need to know how to solve them by hand. What I would do is I would do the elimination technique. I would take the top equation and multiply it by a -2. And that will make it negative 4P minus 10H equal to negative 6250. And then I can add it on down. All right, I can add that down. That'll give me a negative 6H equals a negative 31.25. Kind of odd it worked out that way. Sorry, my math is wrong. Oh. Wish I could focus here.
Now you're a zombie too.
Sorry, I'm having a moment. Too distracted. Seems kind of funny. Negative 30.25. Something wrong with that.
Yeah.
4P minus 10H. Negative 6250 is right.
Now you're a zombie too.
Oh. That's the problem. Negative 29.75. And we divide through by 6. Hopefully, you okay, Mason? Come here. Come here. Come here. This is why we don't run around, especially in the up front. Please go play in the back. I'm too tired right now to do this in my head. If we take a 6 and we enter 29.75, goes in 4 times, which is 24. That leaves 575. Put the decimal up. 6 will enter 57, what? 9 times? 6 times 9 is 54. This is weird. Like, something's wrong with this one. Something is really wrong with this problem. That or it's just me.